In this video, we are going to look at experiments 5 and 6. I'm going to go right to a screen share here. If I can find that. And the first reaction, number 5, is a combustion reaction, and it's a genie in a bottle on fire. So in a combustion reaction, we are going to take methanol and we are going to combine it with oxygen and form carbon dioxide and water. Okay, so if we have a hydrocarbon, or in this case, an oxygenated hydrocarbon, either way, we combine it with oxygen to form carbon dioxide and water. I wrote out the formula for ethanol, CH3OH, or you can say CH4O. And then we have O2, sprinkle off, travels in pairs, and then the CO2 and H2O. This is not a balanced equation, so we will go through and balance that. Let's see, let's start here. I'll put a 1 right here by 1 carbon and 1 carbon here. I have 4 hydrogens, so I'm going to put a 2 here. Now I have 2 oxygens here and 2 more oxygens here. So I have 4 oxygens on the right side, but I only have, I could put a 2 here, but I got this oxygen here. So I think it's going to be 1.5. See if I can write that in here. And let's take a look. I got a carbon and a carbon, 4 hydrogens, 1, and 1.5 times 2 is 3. So I got 4 oxygens here, and 2 plus 2 is 4 oxygens here. If I did not like those fractions, I could always change it and say it is a 2 to 3 to 2 to 4 ratio that we have right here. Okay, so what products are formed when a hydrocarbon undergoes a combustion reaction? Whenever a hydrocarbon or an oxygenated hydrocarbon undergoes combustion, the main products are CO2 and H2O. Could you get carbon monoxide or soot or something in small proportions? Yes, but we're going to assume CO2, H2O unless directed otherwise. In combustion reactions, just like the genie in the bottle reaction we did last time, or the old foamy reaction with the hydrogen peroxide, it's another exothermic reaction. It gives off heat and it feels warmer. The heat's given off to you and you feel warmer when you put your hands by this reaction. All right, what's this going to look like? There is actually a video you can watch that's posted right after this. It's a short 20-second video, but we're going to do a combustion reaction in this big whoosh tube. So it's going to be a whoosh tube video that you can see. All right, I'm going to go to a synthesis and dynamite soap reaction right here. And I think I'm going to just erase that. Oops. Let's erase this. And in this reaction, it's just going to be synthesis. We're going to take hydrogen plus oxygen, forming the simplest compound between them is water. So hydrogen travels in pairs, oxygen travels in pairs. So it's H2 plus O2 forms H2O. That is not balanced. Notice we have 2 oxygens here, so we got to put a 2 in front here. And then if we put a 2 there, we're going to have to put a 2 in front here. Okay, there's the procedure for making the dynamite soap. And what's going to happen is a larger volume of hydrogen or oxygen consumed in this reaction. Look at the balanced equation. Because we follow, these are all gases, and we follow Avogadro's hypothesis that says equal volumes of gases contain the same number of molecules. So the ratio of the molecules of gas is the same as the ratio of the moles or molecules in the balanced equation. So there should be 2 parts hydrogen to 1 part oxygen by number of moles, or 2 parts hydrogen to 1 part oxygen by volume of gas. And if you look at the instructions below for making the dynamite soap, we have twice as much hydrogen as oxygen in that container, because that makes a combustible mix. Okay, then what happens is we are going to light that soap in somebody's hands, And why doesn't this explosion hurt your hand? Well, there's a couple things going on. One thing, if the explosion is closed, it's going to burst a hole in something, but the hands are open to the environment. The other thing is that if it creates a little bit of a spark, what happens, your hands are wet with the water, and that energy, instead of burning your skin, would be diverted to warming up the water. So those are a couple reasons why the explosion wouldn't hurt your hands. Again, there's a video. This one's about a 2-minute video. It's actually the science teacher performing this trick on David Letterman a few years back, maybe quite a few years back. All right, so that is this final reaction. Thank you for watching.